Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem, and here we have 3 to the power of n plus 6 to the power of n equals to 2 to the power of n, and we will solve this problem for the real values of n. So the very first thing we are going to do is, here first you will focus on both of the sides, and you have 3, 6 and 2. So now first I can divide each of the side by 2 to the power of n, so that here I can divide 3 to the power of n over 2 to the power of n plus 6 to the power of n over 2 to the power of n equals to 2 to the power of n over 2 to the power of n. So here you see that now we will just apply the nice exponential formula, and you know that if we have a over b and its whole power n, it is equals to a to the power of n over b to the power of n. So here you see that we have these two numbers and its whole exponent is n, so we can just combine these exponent by using this exponential law. So that according to this exponential law, we will just combine the exponent of the terms of left hand side. So we will get 3 over 2 and its whole power n, plus here we again combine the exponent of 6 over 2 and its whole power n, and here you see that these two are gone and you will get here only 1. And now in the next step you will just make some little bit simplifications here, and you get 3 over 2 and its whole power n, plus here you have 2 3s are 6 and you get 3 to the power of n equals to 1. So in the next step you will focus on the left hand side, and here you see that we have 3 over 2 and its whole power n, and we know that 3 is greater than 2, and if 3 is greater than 2, then we move this 2 in the left hand side and you write 3 over 2 is greater than 1. And if we will take the power n on both of the sides, then you will get 3 over 2 and its whole power n is greater than 1. So now here I can use an important fact about the increasing or decreasing function, and you know that if you have a number which is b to the power of n, and this b is greater than 1, then we will say that this number is increasing function. So here we will just use here this nice important fact, so that according to this fact, here you see that our 3 over 2 itself is greater than 1, then we can say that 3 over 2 and its whole power n is the increasing function. And here if you can apply this rule here, then you can easily say that 3 is greater than 1, so 3 power n is also greater than 1, so 3 power n is also increasing function. And now you see that in the left hand side we have the sum of two increasing functions, so we just know that the sum of two increasing function is also an increasing function. So it means that our left hand side be the increasing function and our right hand side be the an constant function. So you know that the increasing function will be looks like in the form of this one, and an increasing function always looks like in this form, because this function increasing infinitely, and you have 1 with a constant function, and you know that the graph of a constant function is a straight line. So when you can draw this straight line, then this increasing function and this constant function intersect at this point. So here we see that we can just say that this point be the solution of this problem. So this point be the final solution, so that now we find the value of this point. So in order to find the value of this unique point, I can just find the value by inspection. And here we have the our given question statement is 3 to the power of n plus 6 to the power of n equals to 2 to the power of n. And now I can first put here n equals to 0, and we check the behavior of this function. So that when you will put here n equals to 0, then on the both of the sides, then it will becomes 3 to the power of 0 plus 6 to the power of 0 and equals to 2 to the power of 0. So here you have something power 0 equals 1, and it is 1 plus 1 equals to 1, and it will becomes 2 equals to 1. So it is not possible, so that we will reject it this value. And now we can move at n equals to 1. So when you put here n equals to 1, then this equation will becomes 3 plus 6 equals to 2, and you have 3 plus 6 is 9, and it is equals to 2. So here you see that it is again not possible, so that we will again rejected this value. And now we will put here n equals to minus 1. So when you will put n equals to minus 1, then this equation will becomes 3 to the power of minus 1 plus 6 to the power of minus 1 equals to 2 to the power of minus 1. And now we can solve this equation, and here we can write 3 to the power of minus 3 as minus 1 as 1 over 3, and you write 6 to the power of minus 1 as 1 over 6, and you have 1 over 2. So in the left hand side we will make the LCM. We take the LCM of this equation, and the LCM of this is 6, and when we divide this 2 by 6, then 3 by 6, then you get 2, plus we get divide 6 by 6 and you get 1, and this whole equals to 1 over 2. So here you have 2 plus 1 is 3 over 6 equals to 1 over 2, and these two terms are cancelled by each other, and we get 1 over 2 equals to 1 over 2. So this shows that n equals to minus 1 satisfies the our given question statement. So this unique point or point of intersection of increasing and constant function be the point which is n equals to minus 1. So this is the our final answer of this problem, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.